Hi, my name's Josh King, and I hope you've enjoyed your day so far here at Serverless Days ANZ 2020. I'm a sysadmin and a Microsoft MVP in the Cloud and Data Center Management Award category. So I've got a very ops-heavy background, and that's the lens through which I approach all things serverless and DevOps. Today I'm going to be talking about Azure Durable Functions, and how I'm able to leverage my automation tool of choice, PowerShell, within them. So I'll start by answering the question, what are Azure Functions? Well, it's a service in Azure which allows you to run small chunks of code without having to worry too much about the underlying infrastructure. And that code can be triggered by given events. Now I know this is Serverless Days, so none of that would have been news for a lot of the attendees here. And in fact, I'm sure many of you have already dived into Azure Functions using your language of choice. So on the supported languages list, there's many languages that you'd expect to see there, say C#, JavaScript, Python. But happily for me, there's also PowerShell. What this allows me to do is to move my scripts from a dedicated host on-prem up into the cloud and run them for less costs than the Windows license they were previously consuming, and enabling easier integration with other Azure services. Now, I'd originally wanted to demonstrate simple Azure functions with PowerShell before diving into durable functions, but it turns out that demoing two different things in half an hour is a bit of a stretch. So let's go straight into how durable functions are different than straight Azure functions. So durable functions are just an extension that sit on top of Azure functions, enabling a number of stateful application patterns. There's currently 3 supported with PowerShell, with a couple more on the way. The first being function chaining. This is where you've got a number of functions, and they pass their output as input to the next function down the chain. The second is actually the namesake for this talk, and it's the fan-out, fan-in pattern. In short, there's some sort of input which then feeds into multiple instances of one function, which will execute in parallel, and then the output from those are aggregated and output again. The last is the async HTTP pattern, which enables you to have long-running scripts and still satisfy external services, or even other Azure services like Logic apps that are expecting a response back within a given time. This one's very handy, and it's actually how I got into durable functions at first, but it's a little bit outside of the scope of this talk today. So we're about to dive into a demo, but before we do that, we need to lay a little bit of groundwork. The first is we need an Azure account. If you don't have one, you can sign up for a free trial. There is actually a short link for that on this slide. That's toast.click/aztrial. We're also going to be using Visual Studio Code, and within that we'll need to install the Azure Functions extension. And then we also need the Azure Functions core tools. My preferred way of getting that installed is via Chocolatey, and you can do that with choco install azure-functions-core-tools-3. That 3 is important because it dictates which version of the Azure Functions that you're going to be running on, and we do need version 3. So let's jump into a demo. So we're actually going to start today in the Azure portal, and that's so that we can pre-create our function app. We can do this via Visual Studio Code, but it does take a bit of time. So for the sake of getting through this demo, I'm going to create it here, then move over to VS Code, and we'll continue working there while the creation of the backend services continues in the background. So we go into the portal and search for function, and click on Function App. Then we'll add a new one. Then we need to choose a subscription. The one I want to use is already selected, and create a resource group. So I'll call mine RG-Serverless Days. Then we need to name our function. This does need to be globally unique, as it is resolvable over the internet. Then we pick a runtime. So for me, that's PowerShell, and the version is 7.0. Now on the hosting front, we do need a storage account, and I'm going to leave the name that's been automatically generated, and we will be using the serverless consumption plan. Now for monitoring, I do want to enable application insights because troubleshooting these things can be a bit of a pain without that. And I will go ahead and create our function. So once it's reviewed, we'll click create and then head over to VS Code. So I'm in a blank workspace in VS Code, and I already have the Azure Functions extension installed. So I can open that from the left-hand side by clicking the Azure button. And I'm already logged in, and I can see my available subscriptions. If I wasn't logged in, there would be a sign in to Azure link up the top, which would open in your browser and allow you to authenticate with the desired account. To get started, I'm going to click the Create New Project button. And this is going to ask me where to store the files. I'm going to pop that on my D drive under Git. And we'll call this func Serverless Days to match the function name that we just created in Azure. Next, I need to choose my language again, so PowerShell. And then it'll ask me to use a template, and I'm going to skip that for now. Now, I started in a blank workspace, so I'll just add it to the current one. And it'll think for a moment. And then we end up with a scaffolded function app without any actual functions in it yet. It has recommended that I install some recommendations. So I've already actually got Azure Functions installed, and it's recommending the PowerShell extension. I've actually got the PowerShell preview extension installed, and I can't run both at the same time, so I'm going to ignore that recommendation. Now, before we create our first function, let's have a look through some of the files that have been created for us. The first is this requirements file, and by default it lists the AZ module. Now, any modules that you list here will be installed automatically when you go to run your function app. The AZ module is very handy, but it's also very large, and we're not going to be using it, so I'm going to remove it so that it doesn't end up getting installed unnecessarily. And then in the profile, there's also a section here for connecting to your AZ account. It does only work if the module's available, which we've just removed, but I'm going to comment it out anyway so it doesn't even execute. Now, this is a standard profile file, just like you'd find on your workstation. So if there's any aliases or variables that you want to set up ahead of time, this is where you can do it, and they'll be available within your functions. Finally, if we were running these functions locally, which we should, but we don't have time for today, we need to specify the version of PowerShell to use. So durable functions are only supported on PowerShell version 7. So we need to specify that in the settings.json file, as so. Durable functions are made up of a number of components. There's the HTTP starter, which is your interaction point to trigger your durable functions. There's an orchestrator, which handles the workflow of your function. And then there's actual activity functions, which are the components that do the work. For our demo today, we're going to be creating a durable function that takes in a list of addresses and then fires up a number of functions that are going to go out and test those addresses to see if the SSH port is open. To do that, we'll start with our orchestrator. So I'll press Ctrl-Shift-P to bring up the command palette and search for create function. And now it presents me with that list of templates again. So I want to start with my orchestrator, so I'll choose Durable Functions Orchestrator from the list. Then it will ask me to name it, and I'll call it Func Orchestrator. So the boilerplate code here doesn't too closely match what we're going to do. So I'm going to remove it and start from more or less scratch, just leaving in that parameter block. So when we call our function, I'm going to be providing a list of addresses as a query on the URL. And I need to split that into individual addresses, and then so that we can process them. So what I'll do is assign those addresses into a variable called workbatch. You could name this anything. And I know that context is the context of my orchestration. So when it's fired, you can provide input to it, and that is available on the input parameter. And then I'm going to be calling the list of addresses just simply address. Now, one quirk about this is that when it gets to this point, despite this just being a string, it's actually represented in the form of I believe it's Newton JSON object. So I need to explicitly change this to a string using the toString method. And then I can call the split method to split on a comma. That's going to give me a collection of addresses that I can iterate over. So I want to action each address individually, and I'll do that with a for each loop. So each item in my batch is a work item. And then for each address, we need to go and call an activity function. Remembering activity functions are the actual functions doing work. We do that with the invoke activity function commandlet. And then we specify our activity function by name. So I need to remember whatever I specify here is what I'm going to need to use when I create our activity. So to keep the theme with our orchestrator, I'll call this func action. And then I need to provide it some sort of input. That being the actual work item or the address that we're currently working on. Now, by default, if you invoke an activity function, your orchestrator will sit there and wait for that function to finish before moving on to the next operation. But because we want to work on a number of addresses at the same time, we need to provide the no wait switch. What that means is it's just going to fire off the activity. It's going to receive back information about how to query and get output from that, and then move on to the next one. So we do need to collect that information coming back out from the invoke so we can go back and get the information. So we'll assign this entire for each to a variable, which we'll call parallel tasks. So at this point, we've got our addresses, we've split that into a list of addresses, we're iterating over that, and for each address, spinning up a function. Now we need to wait for those functions to finish. So to do that, we use the wait activity function commandlet, and pass in the tasks that we're waiting for. So we'll provide that parallel tasks collection that we created above. Now I'm going to assign that to a variable, and we'll end up outputting that. Now, one thing that I want to do with this output is I want to display it in a specific order. Now, I know that when I create my activity, I'm going to be returning an object with two properties on it, that being the address that we targeted and whether or not the SSH port is open. So I'm going to sort the output from our activities by the port open property and the target property. So at the moment, this, if we triggered this, it would do nothing because it wouldn't be able to find our function called funcaction. So let's go and create our activity function now. Again, press Ctrl-Shift-P to bring up the command palette and head into create function. And this time we want a durable functions activity. And I'll give it the same name as I provided below when calling it. And hit enter. So this is a nice, simple template. We don't actually need that output there. And I'm going to rename this parameter from name to address. Now, important to note that the function.json file that defines metadata about this function also indicates what that parameter should be called. So we've got a binding in here with a name of name. Now we just changed that, so we need to update it here as well to address. Back in our function, I'm going to use the test connection commandlet to target the address that we pass in. And I'm going to be checking the SSH port, which is port 22. Now this responds either true or false based on whether or not the port's open, and I want to assign that to a variable. But there's also one more potential outcome of running this command, and that's passing in an address that doesn't actually exist on the internet. If that happens, we'll get an error saying that the name can't be resolved, and I want to handle that as well. So the first thing I need to do is make sure that that error is actually a terminating error, because for this command, the default is just to display the error but to continue working. So I'll say error action stop, and now I can wrap this in a try-catch block. So if we do catch an exception, I want to just make my port open variable null, explicitly. So having tested the port, I now need to return some information back to my orchestrator, and we'll do that with a PS custom object. So our target is simply the address, and port open is the contents of our variable port open. So that's our activity created. When this is called, we pass into it an address. We then test that address to see if the TCP port of 22 is open. If it is, we get true. If it's not, we get false. And if the address doesn't exist, we get null. That information, along with the address itself, is then returned back to our orchestrator. But now we need a way of actually starting this durable function off, and that is using a HTTP starter. So again, we hit Ctrl-Shift-P, create function, and this time we want durable functions HTTP starter. The name here doesn't matter too much because we're not going to interact with it directly, but what I'll do is keep it consistent. And for the ease of demonstration, I'm going to make this authorization level anonymous, so I don't need to provide any keys or anything to call it. So this template has a function name coming from the parameters when you call it. And you can see that in the function.json file looking at the route, where it's changed its route from its own name, which you would normally have with an HTTP trigger, to orchestrator/function name. That function name being the name of a given orchestrator. So for us, that would be func orchestrator. This means you can have one HTTP starter that can call multiple different orchestrators just based on how it was called. So that's fine, except the only change we need here is we're going to be providing some input to our function, our orchestrator rather, when it fires. So we do that via the input object parameter on start new orchestration, and I'm going to be providing these addresses on the query of our response. So I dive into the request variable and pull out the query. So my query is going to include a address, which is then pulled out in my orchestrator, split up, and fed into my actions. So in theory, this is ready to go. Now we probably should test this locally, but in the interest of time, I'm going to push it directly to Azure. So we head to Azure and we head to the Azure button and click Deploy to Function App. Choose your subscription, and then it'll find all of the available function apps. So I've got Func Serverless Days sitting there, and I'll choose that. Now, when you push from Visual Studio Code, it does overwrite whatever's sitting in Azure, so it pays to double check on this confirmation that you have chosen the right one, and then go ahead and deploy. Now this deployment can take a little bit of time, so while it's happening I'm going to create a quick script to actually test that this is all working. And I'll start with a pre-prepared list of targets. So I've got a list of targets that I'm joining into one string with a comma separating each value, and that's so that I can provide it against the URL. If you click the output window button down there as an aside, you can watch the deployment happen. So our URI is about to pop up in that output, I hope. There we go. So in the output, it does output the URL to call your HTTP starter on. So I'll copy that and pop it in here. And I need the name of my orchestrator. And then specify address. So I have a URL which points at my HTTP starter and adds a bunch of targets to the end of it. Now I call my URL using invoke REST method. And I am going to get some output from this, which will enable me to get further information. So I'm going to capture that in a variable. So if I run this by selecting it and hitting F8, because otherwise if I hit F5, it's going to try and run my function app. It'll go off and actually trigger my function. Now, the first time you do this, it can take a little bit of time to actually kick in, but that ran quite fast. So armed with that response, if I can spell it right, armed with that response, I get a number of additional URLs which allow me to go and check that orchestration. The one I'm interested in is my status query get. And if I invoke REST method against that, I can see that my function app rang. It's now completed, and I can see my input there. And I can see that it took, 33 seconds to run. And in the output of that, I didn't do it right. Let's go back and fix that. So in my orchestrator, I forgot a $sign. So I had provided the word work item rather than the contents of a variable. Let's go back and quickly redeploy. And we're going to end up with the same Alright, so our deployment's finished. Let's go and rerun it. Because it's so soon after a deployment, I expect this to take a little bit of time. Alright, so we managed to catch it while it was still in a running state. Still running, so if we give it another couple of seconds, we should find it. There we go, it's complete. So now if I have a look at the output of that status, I can see that fake address came up null because it's an address that doesn't exist online. Then I've got 2 DNS servers and 2 addresses for my blog, which all came up as false because I don't have SSH open on those, and SSH isn't open on those DNS servers. But there is one address down the bottom here for a service that does have OpenSSH, so it's reporting the port is open. So that's all working now that we fixed that little typo. Alright. So I've not really covered too much of why an ops person like me would get into Azure Functions and durable functions. But I thought I'd answer the why of that with a little bit of what. So my first ever Azure function was a bit of code that goes off to my blog twice a week, pulls a random blog post and tweets about it. So it was a fun little experiment to get me started. Then I've also got a HTTP based function which I can provide a Windows version to it, and it reports back to me what sort of support's still available in it, which then enables me to integrate that into my reporting scripts for, say, colorizing specific machines based on their support levels. And then finally, I've got a work-related project which I can't show, but it's what got me into durable functions. So it's a rather monolithic project that involves Azure Functions, durable functions, logic apps, automation accounts, key vaults, a lot. And it involves taking in alerts, processing them, and shipping them off to another system. Now, some alerts can be triggering and some can be cleared. And what I wanted to do is, if I got a cleared alert, I wanted to hold on to it for a couple of minutes, just in case I was getting emails in a funky order, because I didn't want to try and clear an event before I'd actually got the email that triggered the event. And that's when I found out Logic Apps needs a response back within 2 minutes, and then how the async HTTP pattern solves that. So what now? There's a number of aka.ms links on this slide. The top one takes you through to a lab environment where you can try out Azure Functions, although I don't think you can do PowerShell-based functions through that. I'm not 100% sure on that. The second link takes you through to the official Microsoft Docs for Azure Functions, and then linking off from that is durable functions specifically. And the last one is a sign up for the Microsoft Dev Community newsletter, which also includes invites to workshops and training type events. So thank you for coming to this session. This slide deck and code will be available on my GitHub at toast.click/talks soon, if it's not already there. And if you're interested in some awesome Azure swag, head over to aka.ms/Azure Serverless Swag. The folks at Microsoft are going to be picking a few attendees of this session, and you might just find that you end up with some swag sent to you. So thanks Microsoft for that, and thanks again to you for attending this session. Cheers.